Hello again, everyone, and welcome back to Learn Linux TV. In today's video, what I'm going to do is show you guys my automation system. Internally, my fiance and I dubbed it Config-a-ma-jig, and it's awesome, if I do say so myself. It handles just about everything. Workstations, servers, you name it. And in today's video, you're going to get an inside look. And this solution uses Ansible pull. Ansible pull differs from normal Ansible, which uses SSH for configurations. Ansible pull, on the other hand, is able to, pull configuration from a Git repository, and each server is able to run the configurations via localhost. That means every server or workstation is responsible for configuring themselves. But since I have a specific profile for each workstation and server, everything that is configured through the solution gets a specific customization that is geared towards that particular instance. In this video, I'm going to show it off, and you're going to see everything in this video. Before we get started, though, I just want to mention that I'm not going to be showing you how to build your own automation solution in this video. I pretty much already did that in my Ansible series anyway, but I've been developing this solution since around 2016, so it's pretty much impossible to show you everything in one video without this video being 5 or 6 hours long. So what I'm going to do instead is show you the most notable highlights of this solution. You're going to see how it works, the options that are available, and some of the decisions that I've made when it comes to developing the solution. The idea here is not necessarily to show you how to build your own. Again, I've already done that. But instead, I'm going to give you some details that might serve as inspiration for you when you make decisions on creating your own automation solution. Anyway, with all that out of the way, let's dive in and check out Config-a-ma-jig. All right, so let's take a look. Here I have a tmux session open to my Raspberry Pi back home. I'm recording from a studio today, and I'm actually connected via Tailscale to my Raspberry Pi from my house, and I'm going to show you Config-a-ma-jig and how I develop it. Inside this tmux session, I have a number of VMs that I'm connected to. You can see I have one for Alma Linux, Arch Linux, Debian, Fedora, and so on. This first node right here is my admin node, so you can see in the bottom which server I'm connected to. This is the node that I developed from. And right now I am actually inside my Git repository. So right there you see some of the files that I have inside that Git repository. We'll be going over that in more detail shortly, but I wanted to talk a bit about how I actually developed this. So if I show you my branches, you can see that I have 3 branches. The testing branch is what I developed from. Each one of these nodes down here, anytime I commit to that branch, they automatically check out the code and run the code. So basically what I do is I develop from the testing branch, and if it succeeds on each one of these VMs right here, then I am able to commit that to production. After some time passes and the code that I commit proves itself, it gets updated or promoted to the next branch. So first, code changes go to testing, then to production, and then to stable. So machines that are on the stable branch see the fewest changes. Essentially, the instances that are public-facing, like websites, for example, those are usually on the stable branch, and then internal tools are on the production branch. Now, the star of the show and the first thing that I'm going to show you guys is the provision script. So when I'm using this solution, I use the provision command, which is a bash script, and that gives me pretty much all the functionality that I need. So if I show you the help menu, you can get an idea for some of the things that I can do with the provision script. As it shows there in the verbiage, if I run provision without any options at all, it's going to run a full system provision. In fact, I'll show you that right now. So right here, I'm on my Alma Linux machine, so I could type sudo and then provision. I need sudo because it's going to be making changes to the system, and that should be it. I press enter, and then it's going to automatically configure my entire server for me. I only need to run that one command, and then it downloads all the instructions from my Git repository and runs through all of the configurations specific to that machine. Now, obviously, each one of these servers are different distributions. So you're going to have different package names and things like that to deal with, but I use variables for package names, so that way I can just use or reference the variable name within each VM, and then in the variable file for that particular distribution, I simply change the package name to whatever it's supposed to be. So here we have Linux running, and it takes about 2 minutes for a full system provision. Now, one thing to keep in mind here is that if I don't use the provision command at all, then it's going to automatically run in the background. Now, I'm going to show you that right now. As you can see from the help menu, there's a status option, -S, so let's go ahead and run that on my Arch machine. I don't need sudo for this, so I'll just simply type provision -S, and it tells me the next time it's going to check for changes. If I commit any changes to the Git repository, it will run. However, if I haven't made any changes, it's not going to run at all. I don't want the provision solution to run for no reason. So anytime I commit changes to a particular branch within the repository, it's going to detect that the next time it runs and then provision the machine accordingly. However, again, if I haven't made any changes at all, it's just not going to do anything. In fact, I'm going to show you an example of that. I could type systemctl status provision, and we can see right there in the output, it says repository has not changed, quitting. So that's an example of a provision run that didn't even need to run at all because there weren't any changes. Now I'm going to go back to the options here, and I'll also explain a bit more about how in particular the provisions do run. But right here we can see some of the options that I've written into my program. For example, -C is check mode. It's not actually going to make any changes at all. It's a great way to test my code just to make sure that I don't have any syntax errors or anything like that. I also have the -D option, and if I use that, it's going to disable the provision timer. I use systemd timers for the provision. That's what's going to trigger the provision. But sometimes, like right now actually, I'm recording from my laptop and I really don't want it to provision during a recording. So I've already disabled the solution here on my laptop. After a while, if I want to re-enable it, I could simply use the -E option. Now here we have a provision run that's still in progress. However, if I want to follow the progress of a run that's already going on in the background, I could use provision -F, which isn't going to do anything right now, obviously, because there's nothing running on this particular machine on my Raspberry Pi. But if there was, I would see the same output that I see right here. And you know what? It's already finished. The Linux provision run has finished. You can see that 311 tasks have completed. There weren't any changes because I haven't made any changes to the repository. 0 have failed, and unreachable is 0. Now, unreachable is pretty much always going to be 0. That's just an Ansible thing. I use Ansible pull, and that's how I get my configuration changes. Ansible pull is something that I talked about in my Ansible course. If I scroll all the way up to the very top, right here, we can see the actual provision command that runs when Config-a-ma-jig runs. So here we can see that I'm using Ansible pull. Again, that's something that I went over during my Ansible course. I provide a vault password for the encrypted files, so that way they could be decrypted as it runs. I'm going to accept a host key. It shows the location of my private key, and then the repository where all the code resides. Here, I could choose which branch I want this machine to run on. It's on the testing branch, like I mentioned before. And run.yml is basically an index playbook that pulls in everything else. So I'm going to run that playbook, which is inside the repository. And then from there, it's going to go through all of the instructions that I've written for this particular machine. Other options that I have here is a reset option. So if I was to run sudo provision -r, which I'm not going to do right now, but if I did, it's going to clear the cache. And what that does is causes Config-a-ma-jig to run again, even if there weren't any changes. It uses a local cache to compare the changes to the repository. That's how it knows whether or not something has changed. But if I want to trigger this to run in the background, then I could run sudo provision -r for reset, and that's going to clear the cache. At that point, when the next time for a provision comes around, it's going to run because the cache is completely empty. So Config-a-ma-jig thinks that it hasn't run at all, and then, well, it runs. In this case, we have 33 minutes left until this particular node is going to run a provision job. I could type the same thing here, and you can see that this particular node has 5 minutes left until it goes to provision again. And I have a random number between 1 and 60 when it comes to minutes because I don't want my nodes to provision at a predictable time. That allows threat actors to determine when your config solution runs. For example, if someone gets in the system and they have that long to do whatever they're going to do, that might just help them out. But I want to make that random because I really don't want any predictability as far as when a server provisions. It's just a security thing. Anything that's a predictable pattern can be used by threat actors, so I like to randomize the minute from 1 to 60 for when each particular node checks in. Going back to my help menu here, we can also see that I have -T for tags. And a good reason why I might want to use that option is if I don't want to go through an entire provision run if only one particular thing needs to be changed. Now, granted, it only takes 2 minutes for a provision run to go through anyway. However, sometimes I want to test a particular thing, so that way I could provide a tag and it'll only run tasks that have that particular tag. Another option that's useful is provision-v. And what that does is show me some interesting information here. We see the application version, the provisioner version, and also the distribution group. Distribution group is just another fancy name for branch. So we are on the stable branch on this particular node. Again, this is my Raspberry Pi node, what I use to develop the software with. So I put this on the stable branch because I really don't want it to change all that much. Now, if we compare it to my Alma Linux VM, for example, we can see that the distribution group is testing. We can also see that the version number is different. This machine right here is running version 2.2. And this one is running version 2.1. Again, new versions hit testing first, then production, and then stable. So stable is going to generally be 2 versions behind testing, if that makes sense. Now what I'm going to do is show you some random config files, so that way you could get a better idea how I accomplished what I've accomplished. Again, here we have the repository for the code. If I go into roles, you can see some of the roles that I have here for this instance. Now, managed instance is a role that's applied to every single node, regardless of the distribution group or custom configuration. Managed instance basically provides Config-a-ma-jig to the machine. So the provision script, how the options are configured, everything that is specific to Config-a-ma-jig are in that particular role. Another role that's applied to every single server is Linux instance generic. And that's basically what the name implies. It's just a very generic configuration, a base level configuration, if you will. Basically things that I want to happen on every Linux server or workstation for that matter, that's not specific to anything else. So if I want to add my Vim config, my tmux config, or SSH config, things like that, it goes in Linux instance generic because that applies to every single machine. Similarly, I have Linux server generic, which is the same thing, but it is specific to servers. From there, I have very specific roles, like a Nextcloud role, a role for the Cosmic Desktop, the GNOME Desktop, Sway, and so on. Now what I'm going to do is open run.yml. If you remember from earlier, that's the first playbook that runs. That's the index for everything else. So let's just open that up and check it out. And here we have it. So we have some pre-tasks because there's going to be some things that I want to happen before anything else happens. So the pre-tasks, I just use that to essentially set up the session for Config-a-ma-jig. You can see that it's pulling in a playbook called app startup. But that's something to take note is that it's going to run some pre-tasks, again, something I covered in my Ansible course, that's going to set the environment for everything that comes after. Continuing, right here, I have hosts all, and then we're applying the managed instance role. Now, I mentioned earlier, managed instance is one of those that applies to everything, so I'm not going to differentiate anything here. I'm literally saying all hosts need to have this role right here run against them. I also have a baseline config, the same one I mentioned earlier, Linux instance generic, that applies to every single server. Now, as we scroll down here, we start to see some differentiation here. Linux workstation generic, for example, that's going to apply to workstations. Linux workstation cosmic, that group is going to apply the Linux workstation cosmic role. And then we have further roles down here, server roles, for example. My Nextcloud role is only going to apply to my Nextcloud server. It's able to build an entire Nextcloud server completely hands-off that's ready to go right after it runs. Now, similar to how I had pre-tasks at the very beginning, I have some cleanup tasks that are going to run after the solution is finished. App shutdown.yml, for example, that's what's going to run when everything comes to a close. And one of the things that does is send me a message via pushover to my phone. So my phone lights up anytime I commit changes to my repository, and then those changes run against servers. It reports to me whether or not those changes were successful. As an aside, I also use healthchecks.io, which is a solution you could use to make sure that something doesn't silently fail, because the last thing you want is to get no notifications from your solution and then assume everything is fine. If something silently fails, then it's not running at all, and you might assume that it is. So I have a 1-week timeout for this solution, and if a node doesn't check in within that time, it's going to send me an alert. Now, another thing that's going to happen as well is there's going to be a weekly reset. So right here, I have a provision reset timer. So when this runs, what it's going to do is clear the cache. This is going to ensure that within 7 days, there's always at least one run of this solution. And again, healthchecks.io is watching this, so if it doesn't get a ping within a week, it's going to send me an alert. And this is how I make sure that, again, it doesn't silently fail. And you know what? I've mentioned systemd a few times now, so what I'm going to do is show you some of my systemd units that makes this solution work. First of all, what I'll do is show you the contents of the provision service itself. So provision.service is what runs the solution itself. It's triggered by the timer. The timer triggers the service, if that makes sense. And there's nothing too fancy going on here. What it's going to do, as you can see under exec start, it's going to run the provision script. So when this service runs, that's exactly what it does. It waits until the network is online. That makes sense because it's going to be downloading information from a Git repository, and it can't do that if there's no network connection. So in this case, it's going to ensure that the network is online before it starts to run. I mentioned that the service is triggered by the timer, so let's take a look at that. And here we see the timer. In this case, I have a randomized delay of 34 minutes. Even the randomized delay is somewhat random. I definitely don't want anything to be predictable. One thing that's worth noting here is that on boot sec is set to 10 minutes. This means that when an instance starts, it's not going to provision until the machine has been up for at least 10 minutes. And the reason why I set it up this way is sometimes I might have a virtual machine that I don't want to be on all the time. Maybe I just want it on whenever I need to use it. And the last thing I want to do is turn it on and then have to wait for a full system provision before I can start using it. So I have a 10-minute window before the first provision starts. That way I have a chance to disable it if I don't want it to run. In this case, we could also see that it's going to repeat the task every 57 minutes. So whenever this particular service kicks off, again, the randomized delay is 34 minutes. So if it starts 20 minutes past the hour, then it's going to be every 57 minutes according to that particular schedule. Now we could take a look at the provision reset service. And again, this is what's going to force a cache reset once a week. In this case, it's running the -- reset option of the provision script, which we can see right there in the help menu resets the cache. We can use -- reset or -r. Both will do the exact same thing. And we can see the option -- reset applied right there to the provision script. So the provision script is pretty much the brains of this operation. And considering that I'm using systemd, it allows me to do things like this. I can check the status of the provision service, for example. And we saw that earlier, but one thing to pay attention to is that this unit is disabled. This service is disabled. And the reason for that is because the timer is what triggers this service. So there's really no reason for the service itself to be enabled because the timer takes care of that for me. So if I take a look at the provision timer again, we can see this one is enabled. So the provision timer will start as soon as the system starts, and then when the timer triggers, it's going to trigger the provision service. Now, something that you'll also notice, if I was to run this on another machine, I'm going to trigger it manually. This time I'm going to trigger it on my Arch Linux machine. And something to mention about that is if I manually trigger a provision run, it runs no matter what, regardless of whether or not there were changes to the configuration. If I run sudo provision, it's going to not care about the cache and just run everything. So press enter here, and we can see some information that I want to show you. First of all, when it runs, it gives you the same information that is shown during the version information. And although you're not seeing it now, there's a wall message that appears as soon as the solution runs. So what I'm going to do is just make a change to the repository. And what that's going to trigger is all of these nodes down here to check in. Arch Linux is already running. We can see that Debian is not. So let's check the status of Debian. 28 seconds left. Probably not going to hit that in time. What I'm going to do right now is just implement a simple change. So right here, I have an in-progress version information file. As I develop it, I simply write information here for exactly what's going on or what I'm developing. So I'm just going to simply say test right here just to implement some sort of change. You can see that that file has changed. So all I have to do, I'll commit that change, and then I'll push it up to the testing branch. And there we go. So before I showed you that none of my nodes are running this automatically because there weren't any changes. But now I've implemented an actual change. So anytime any one of those nodes down there decides to check in, they're going to see that information or configuration has changed and then start running. My tmux configuration is going to show a blue color for a machine that has activity. Arch Linux has activity because I triggered that myself. But what I'm going to do is just sit right here for just a moment, and then we'll see other nodes start to light up. That means that they're starting to implement changes. Here we can see OpenSUSE has already started to provision. You can see that the Raspberry Pi instance has started, Pop! OS has started. If I go to any one of these nodes that provision automatically in the background, you can see that it popped up a message. It's literally telling me that Config-a-ma-jig is running in the background. Part of the application startup procedure is it's going to produce a wall message. That way it lets everyone that's logged into the system know that a provision is occurring. And the reason why I do that is I never have to wonder why a machine is slow. I mean, to be fair, none of these machines slow down when Config-a-ma-jig runs. But I think it's a good idea to know what's going on in the background. So right here, we see no output at all, but we did get this message right here that's letting me know that it's running. And since it is, I can type provision-f for follow if I want to see what exactly it's doing. You see the same thing here with my Raspberry Pi. This is a Raspberry Pi testing instance. It exists only to test code specific to the Raspberry Pi. So the admin node and the Pi node, those are the only two among these VMs right here that aren't, well, VMs. Everything but those are running within my Proxmox server. So we can see that the Raspberry Pi instance is running, my Pop! OS instance is running, and we see OpenSUSE is making progress as well. Since I'm in follow mode, I can simply hold Control and press C to break out of follow mode. Since it's running in the background, it doesn't really matter whether I'm looking at it or not. It's just going to run. Anytime now, we should start to see some messages when this solution finishes. I mentioned that it shows a message when it starts to run in the background, and it also shows a message when it's finished as well. So we see activity here in Alma Linux. In this case, it just started in Alma Linux. But here on the Raspberry Pi, it finished. So we see the message that came up when it started to configure the server. We also see the message that comes up when it's done configuring the server. That way, if I wanted to wait for it to finish before working with the server, I could be notified when it's done, and then I can continue working. Now, part of what makes this work is in the app directory. I have several directories within there. I also have a config directory. And right here, let's just take a look at app.yml. Let me clear the screen first. And this is where some of the options are set for the solution. Under Ansible solution name, if I ever got tired of the Config-a-ma-jig name, I could simply rename it in that one place, and then the entire solution will be renamed accordingly. It's also where I set the Ansible solution version, the Kickstart script version, and the provision script version. Now, I haven't mentioned the Kickstart script before. That's just something that I use to install Config-a-ma-jig. I can drop that file on any server, run it, and Config-a-ma-jig is installed. Now, the version numbers are completely arbitrary. I just simply increment those as I feel it's relevant. So 2.2, as of the time I'm recording this video, that's the in development version. I'm implementing changes in that version. And then whenever the changes are, done, then 2.2 graduates to production. This particular node is on the stable distribution group, so it's currently at version 2.1. So at some point when I finish 2.2 and then that gets committed to stable, then this node will be upgraded to version 2.2 as soon as that happens. Next, what I'm going to do is go into distrovars. I mentioned earlier that I use variable names for various things specific to distributions. So you can see right here, I have a variable file for each distribution that this solution supports. So I'm able to support Linux Mint, Fedora, Debian, Arch, Pop! OS, and so on. Randomly, I'm going to open up ubuntu.yml, and you'll see what I was talking about earlier when it comes to distribution package names being different from one distro to the next. I could use these variable names across all of my playbooks, and then it gets differentiated by whatever the distrovars file has for that particular variable. So, for example, the hunspell package in Ubuntu is hunspell-en-us. iperf is iperf3. You see the Linux firmware package. You see the OpenSearch version that I use for various things here. I have a path for the ini file for PHP. There's a lot of different things that can be different from one distro to the next, so I maintain these files with all the differences, so that way I only need to refer to the variables in each file. I don't have to find and replace anything across all files. I only need to change the information right here. Now I'm going to show you my secrets file that has all of my secrets in there, API keys, passwords, everything you might ever want to know. Let's check that out. And it's encrypted. Gotcha. So I use encryption on all files within my repository that contain sensitive information. That way, if somebody was to get my secrets file, they don't really have much of anything, really, unless they have access to my encryption key. Then right here, this is the best thing they're going to get. However, what I will do is show you an example of that file that's a little bit more benign and also not encrypted. So I'll go into my docs directory, and then in my sample configuration directory, and let's check out my secrets file that's not encrypted, which just includes basic information, nothing that actually pertains to anything. I use this as a template if I ever want to, redo my secrets file or anything like that, or remember how I set different things. So you can see right here the information that would be in my secrets file if it wasn't encrypted, with just some basic information in the double quotes that really doesn't matter if anyone sees this because it's just sample information. But this gives you an idea of what that file actually looks like if I were to decrypt it. Now, you might be wondering how exactly I differentiate one distribution from the next, because if you've used Ansible pull before, then you know it's using localhost, and each of these machines are going to be called localhost. So how do I figure out or tell Ansible to run certain things based on the node? So here's what I'm going to do. Under config, I have my node assignments file. And then you can see some of the configuration values here. This is how I map a host to a particular role. So Linux instance generic, that gets all those. Now Linux instance generic is going to be applied to everything. But sometimes I might only want the generic role and nothing else. So if I have a host listed right here, it just means that I want only the generic role to run on that host. And one of the reasons why I might do this is I might have a more generalized server. Maybe it's just not important, but I still want my configuration. It doesn't really matter if that machine gets deleted, or perhaps it's a demo machine that I use for this channel. Then this is going to give it a basic level of configuration. That's also why I have very generic host names here. So if I'm setting up a Debian server for the channel, I might just simply set the host name to Debian or Fedora, Pop! OS, whatever it happens to be. Now, as we start to get down here, you can see some of the actual roles and host names that I use. You can see my host name format, so Linux Server Generic. You can see my admin node, which is actually the one that I'm on right now, my Raspberry Pi testing instance. You can see several machines with testing in the name. All of those are part of a CI/CD system, and that's essentially what you're seeing right here. Inside my tmux session, I have a session open to each one of these testing VMs that allows me to see pretty quickly how my configuration changes pertain to that particular virtual machine or distribution. This gives me an idea after I make a config change what exactly happens, and then gives me some time to test it, make sure that everything is fine, and I just make sure that everything is fine on each one of these distributions right here, and that's all I have to do. I only have one Nextcloud server. Now right here, I have regex for node 1 and node 2. I don't even have a node 2, but if I ever did, then it would still apply because this one right here is referencing both nodes 1 and 2. Workstation generic. You can see some of the nodes that I have here. Even Linux instances on MacBooks, so I could test how it works on that as well. You can see my ThinkPad is here, my Gazelle, my Dev1, all of my instances are here. The Cosmic Desktop is set up by this solution. So as you can see here, I have several nodes that have Cosmic installed. I have GNOME installed on many different nodes here. And the GNOME role will configure everything, and I do mean everything, keyboard shortcuts, wallpaper, on the desktop, you name it. It does pretty much everything. If I want a more stripped down instance, maybe I don't want to run full GNOME. Here I have my Sway role, which will do exactly that. It installs the Sway window manager on each machine that's listed down here. And you'll notice there's some duplication. So for example, my Dev1 is listed right here. If I scroll up here, we can see the Dev1 instance, go down to Sway, and we see Dev1 again. And I'm okay with duplication like that because sometimes it just makes sense. I might want to install Sway on a node that previously had GNOME, and the installation of one doesn't take the other away. It just adds to it. So that way, when I go to log into my instance, then it's going to enable me to add that particular desktop environment, or in this case, window manager, to that machine. But this gives me ultimate flexibility for how I configure each node. Now, I mentioned earlier that the provision script is basically what does all of the work. So I'll go into roles. Let's go into managed instance. And then templates. I have a very specific directory structure here. And then underneath scripts, you can see that I have a template file for each of the scripts that makes this solution work. Now you might notice something called a provision watchdog that's listed here as well. That's another failsafe. Now, obviously, if I get an alert from healthchecks.io that my solution hasn't run, well, that's a problem. The provision watchdog will try to run it itself if it hasn't run in a while. So it tries to self-heal a little bit. If the provision watchdog looks at the log files and finds out that they're too old, that's potentially a problem. So what it will do is trigger a provision run. And the idea is to try to have as few situations as possible that's going to result in silent failure. We definitely don't want anything to fail in the background. You'll notice that I have two provision scripts, provision.sh and provision_next.sh. The next version is my development version. If I'm implementing a change to the provision script, well, that's a very important change. I mean, the provision script is the brains of the operation, so I really don't like to adjust that directly. What I'll do instead is make all of my changes to the provision next script, and then I can test it out, make sure that it's not broken, because the whole thing kind of fails over if the provision script isn't working, if there's a typo, because all of these scripts are going to trigger the provision script, and if the provision script itself doesn't work, then nothing else will work. So that's why I test all of my changes in provision next, and then eventually provision next becomes the new provision script when I feel like it's had enough time to be tested. Now, I'm not going to show you all of this file right here, but you can see kind of some of the things that I do. This provision script is 311 lines long, and you can kind of see down here how it determines which version to run. I mentioned earlier that it's not going to run if there's no changes. That would just be pointless. So there's going to be a version with tags, there's a version without tags, and then there's also a non-interactive version that runs in the background. And each of these are bash functions, so I run different functions depending on how the provision script itself is being run, which gives me more flexibility. The non-interactive shell version is going to have a fewer things here, because if it's running in the background, for example, I don't need to display the app information if it's running in the background, so I omit that. You'll notice that it's listed here, display app info, and it's not listed here under the non-interactive version of the script. Now, I can't go over everything here in this script. I mean, it's a massive file, but you could kind of get an idea for how I decided to do this. I'll show just a little bit of it here. It would be a video in and of itself to go over this script, but you could kind of get an idea for the syntax for how I actually call this particular solution. So when the service runs or the timer runs, it's going to run one of these provision functions. So I have a tags version, a version without tags, and then right here is the background version of this particular script. Going to go back a few directories here. Now, this node assignments file right here that I showed you earlier, this is the Ansible inventory file. So if you are learning Ansible, then you're already familiar with the inventory file. You could give the inventory file a different name if you want to. And on my end, I call mine node assignments. We've already seen this file. It's this one right here, which basically enables me to add a server to a particular role. But this is just an inventory file. If you've already learned Ansible and you know what an inventory file is, this is no different, 100% the same. It's just under a different name. But how did I do that? How did I tell Ansible that it needs to look for an inventory file under a different name? Well, up here in the base level of my repository, I have ansible.cfg. And we can see some of the things here that I am adding in my configuration. So for example, we have inventory equals, and then the relative path app/config/node assignments. And inside that file, well, you already saw what's inside that file. That's the one that I just showed you. That's my inventory file. I like to keep all of my configuration under a config directory. I like to make sure that everything is in a logical place. It makes it that much easier to find what you're looking for. It shows the log path. I keep my log file in /temp. Obviously, that means that the log file will be effectively deleted at some point in the future because you shouldn't store anything in temp. But since I use systemd, I'm also using the systemd journal, which also means I can run journalctl -u for unit and then provision. And we can see all the log entries because I'm using the systemd journal for all logging. The temp log is just for this particular run. That's how the follow mode works. It's following the temp log while systemd in the background is storing the information for later use. Again, that's why I don't care that my log file is in /temp, because it's only used for follow mode and is not used for anything else. Now, there's going to be quite a bit more that I could show you, but I'm going to ask you guys what you want to know about my solution. It's just that there's so many lines of code in this solution. I think there's over 80,000 lines at this point, so it's impossible for me to show you everything, but the whole point was to give you guys some food for thought. For those of you that have a home lab and need some inspiration, I'm hoping some of what I've gone through in this particular video might help inspire you to make changes to your configuration. Now, if mine looks way too advanced and it's overwhelming, that's totally fine. I've been developing this since 2016. Okay, so 9 years I've been developing this, and having something of this size and magnitude is not something anybody can do in a short amount of time. So don't worry if, you have an Ansible solution that doesn't quite measure up. That's okay, because it doesn't until it does. As you develop it and add to it over time, it just grows and grows. You find problems, you implement solutions to those problems, workarounds, whatever it might be, and then your solution grows over the years, which is exactly what mine has done. Again, I've been developing this since 2016. It's massive, but I figured it'd be fun to show you a little bit about my configuration management system, and I've done just that. And there's our video. I hope you guys enjoyed an inside look at my automation system. I'm hoping that some of the decisions that I made might inspire you guys when you develop your own automation solution. Again, I have a full Ansible course here on YouTube and also an updated one on Udemy that you should check out if you haven't already done so. In the meantime, if you like this video, be sure to click the like button to let YouTube know. Who knows, maybe if you do that, we'll see more Linux-related content here on YouTube. That would be awesome. In the meantime, thank you so much for watching this video, and I'll see you in the next one.